Scientists from the Smithsonian Astrophysical Observatory and elsewhere in the world begin by selecting a tiny sliver of the sky. Vast amounts of data are gathered, computed, and plotted, building up the largest three-dimensional map ever created. While the mapping shows the universe is expanding overall, nearby galaxies can actually be pulled together by gravity. Our own galaxy and Andromeda are actually circling each other and getting closer. The two galaxies will eventually collide in about 3 billion years' time. In a complex gravitational dance over another billion years, they will merge and form a new galaxy. Yet, despite the enormous dynamism of the universe, we know from the movement of the galaxies that something is holding it all together, but we don't know what it is. It's an enormous force that we can't see. Today, our view of Mars is based on data from spacecraft orbiting the red planet, allowing us to explore that world as if we were right there, right now. If there's one place you would visit, this is it. The huge scar across Mars called Valles Marineris. It's the largest canyon in the solar system, 5 times deeper than the Grand Canyon. On Earth, it would reach across the United States from coast to coast. All the clues suggest it may once have contained a great lake of water and the possibility of life. Now, we're moving into volcano territory. The most massive is Olympus Mons, almost 350 miles across and 16 miles high. It is the largest volcano in the solar system. Further out from Mars are some of the most interesting places to explore. The moons of Jupiter. Jupiter has an extended family that includes 4 large moons: Io, Europa, Ganymede, and Callisto, each one utterly unique. Io is a geological hotspot. Volcanoes spew plumes hundreds of miles into space, and huge lava flows cover its surface. In contrast, Europa is cold and smooth, covered with dark streaks and what looks like blocks of sea ice. Beneath the icy surface, there may well be a layer of water. This would be an amazing discovery, the only place we know of outside Earth with lots of liquid water that could support life. One day we may find out. Our space adventure has already given us striking new views of life. As we look back at Earth, we gain new insights into our own fertile and ever-changing planet. We send our remarkable new tools of exploration out into the solar system, because the big question...
He wanted to sit next to you. He wanted you to sit next to you.
Yeah, no, not the whole thing. The whole thing.
Stop. When you
I think it works. Oh, dude, I don't know.
Stop it.
Oh,
You're out of here. Just stop.
Wait, what's that? Oh, that's right. Oh, you need like both of them now. I think, don't you? I don't know. You think it'll work? Can you film it like that? No, because you need both of them. I don't think that'll work.
Got it? No.
You got it?
You always talk to me.
That was wonderful, wasn't it?
I always told you to stop. No, I told you to say you're not going to be able to talk. No, Dad was supposed to sit there.
Just say yes, maybe it happens.
Yes, there was so much fun.
Does he translate things into...
Advanced motion picture system using one of the largest indoor motion picture screens. Complementing the picture, 6 channels of full-range sound located around the theater will surround you and make you feel that you are... For the courtesy of others, please turn off or silence your cell phones and pagers and put away any other electronic devices. We must remind you that eating, drinking, and smoking are not allowed in the theater, and the use of cameras and video recording devices is strictly prohibited. Once the show is over, wait for
Okay, I'm not supposed to be filming in here, so I'm taking pictures with my camera phone. There's Dad and Mom.
Measurement while drilling, combined with directional drilling, is called geologic steering, or geosteering. Use real-time information and
That's once. We're in the Genghis-Khan thing, and I couldn't film or take pictures or anything, so I indiscreetly took pictures with my cell phone. So yeah, here are the Genghis-Khan photos.
Over the borehole of a 7,285-foot well. I'm driving this thing from the cockpit right below you.
That's cool.
Our downhole tests indicate we may have hit a pay zone. We're going to take this marvel of engineering here to the bottom of the well and find out. Hold on up there. We're going down. The steel wall out there is a surface casing. It protects the groundwater from drilling lines. It keeps dirt and softer rock near the surface from caving into the borehole. 1,000 feet. 2,000 feet. We're slowing down after finally getting past the surface casing. 3,000 feet. That's limestone out there. A sedimentary rock that could make a good reservoir. Now we're passing a series of shales, shaly sands, and limestones. 3,500 feet, representing millions of years of geologic history. That's a shale. That's a shaly sand, limestone, and shaly limestone.
No, I'm intrigued.
Oh.
That's my intrigue.
Got it. Got it.
That means I was interested.
Impermeable shale the sea of our reservoir. 6,800 feet. Well logs tell us this next layer should be the pay zone.
Oh, wow.
Texas feet, or maybe some natural gas. Stop now.
Oh, let's stop and go outside.
No, he's gonna go outside. Watch him.
I'm not gonna go outside. It's too dangerous.
Warning, hatch open. Solid rock. Not a pool of oil. But the microscopic holes in it are filled with oil. That right there, that's Texas tea. This looks like a pretty good well. A really good well, in fact. Now we've got to put in the production casing. That's a pipe that goes all the way from the surface down through the reservoir. It keeps the well from caving in and gives the oil and gas a dependable path back up to the surface. Here it comes now. Once the casing is in place, we use